Hi friends, welcome back. Algebra 2, Lesson 2, Red Book, 3rd edition. We're talking negative exponents, product, and power theorems. If you want the circle relationships info, that'll be in part B. This is part A. All right, so really quick, grab your notebook, please. Everybody's been writing down notes, right? You want to write notes for this. The first are our rules of exponents. So let's take a peek at our rules of exponents. Remember, when we have x squared plus x to the third, really what that is x, and then 3 more x's for a total of 5 x's. So you'll see that we end up adding, even though we're multiplying those bases, we're adding those exponents. Over here, we're saying, hey, do x squared 3 times. That would result in us getting 6 x's. So we would have x to the 6th power. The other one is, sorry, I need some more paper to write on because this is going right through. Okay, so the next one is this rule right here. We have 5 over x to the 5th over x squared. What that means is we have 5 upstairs, 2 downstairs. We get rid of the 2 downstairs and get rid of 2 upstairs, and that leaves us with x to the 3rd, which ultimately this is just subtraction. So this one's multiplication, this is addition, this is subtraction. Now, when we have negative exponents, we treat them like we would a negative attitude. So if you're upstairs with a negative attitude, I don't know, maybe your guardian, your parent tells you, hey, go downstairs. You're upstairs and they tell you go downstairs, or if you're downstairs, they tell you to go upstairs. Either way, negative attitudes. First, we're going to turn it into a fraction, because we can turn anything into a fraction by putting it over 1. Now that we've done that, we can move that attitude and make an adjustment. So that attitude where it's currently upstairs, we're going to move it downstairs. And when we do, that changes the attitude to be positive. I'm going to be jumping around trying to find a decent pen that I like. Okay, what does that leave us upstairs? Leaves us with a 1. So 1 over x squared. So that just got rid of that negative attitude for us. Lastly, we have x to the 0 power. Remember, anything to the 0 power is 1. There's another one missing on here. That is the cube root of x squared here. That is the same as x to the 2/3 power, just like that. That's a good one to kind of remember. Okay, with that in mind, let's take a look at these examples. So looking at example A, we have downstairs negative attitude. We got to move that negative attitude upstairs. So we're going to move it upstairs. So now we have 3 to the positive 2 over 1, because once we get rid of everything, we have a 1. It doesn't matter, though, when it's downstairs. And so we just have 3 squared, which is 9. All right, let's look at B. We have 3 to the negative 3. This does not make it negative 27. Absolutely not. Which, by the way, if you haven't already done so, give yourself a cheat sheet with your perfect squares, perfect cubes, perfect 4s. That will come in handy. So this absolutely does not make it a negative 27. This negative in the exponent does not affect the base at all. It is just an attitude. Let's turn it into a fraction by putting it over 1. It's currently upstairs. Let's move it downstairs, fix that attitude. What does that leave us with upstairs? Just a 1. So we now have 1 over 27. Okay, so let's look at this guy. We have negative 3 to the negative 2 power. All we're going to do is take all, and so it's currently upstairs. We're going to move it all downstairs. Negative 3 to the 2nd power. Now, you got to be really careful here. Side note, if you have negative 3 squared, that is negative 9. If you have quantity 3 squared, that is saying, hey, do negative 3 2 times. Negative 3 times negative 3, which is positive 9. You see the difference there? It's vitally important that you use your parentheses appropriately. So like here, this is going to be, it's saying, hey, do this 3 squared part first, because we always do exponents, and that negative is just like multiplying by negative 1. So we always do our exponents before our multiplications. So this is 1 over negative 9, which again can be written as negative 1 over 9. The negative can be in the top, bottom, or the middle. It doesn't matter. What about this guy? Okay, so this is exactly what I was talking about. We're going to put, it's currently upstairs with a negative attitude. Let's move it downstairs. 1 over quantity negative 3 squared. So negative 3 times negative 3 is positive 9. So you see the difference that parenthesis makes? Man, that is going to be a huge one. All right, here, this is currently upstairs. Let's move it downstairs. So we have negative 3 to the positive 3 power. So this garbage right here is negative 3 times negative 3 times negative 3, which would give us negative 27. So we have 1 over negative 27, and a negative times a negative is a positive. So that would be a positive there. Okay, so let's take a look at the next part of this lesson. All right, so with that said, let's use all of our rules that we have here. Oh, I just scratched that out without using any whiteout, and I love my whiteout. Okay, so looking at this guy, if there are no exponents attached, remember it's part of our invisible math. It's an exponent of 1. So if you need to, go through and slap a 1 on some of these. All right, now anything to the 0 power is 1, and all of this is being multiplied, and anything multiplied by 1 is itself, so we can just get rid of that. So what do we have here? We have x2, x negative 5, x positive 5. Well, x positive 5, x negative, remember when it looks like this, we're adding them, right? So positive 5, negative 5, those cancel out. Bam, bam. All right, cool. So we are left with x squared. Then we have y1, y negative 4. Add those together, we get y negative 3. Now, in my opinion, you should not have a negative in your exponent unless the instructions say to do otherwise. So I would fix this to say x squared over y to the 3rd power, and that is the example. That's the answer I would give. Okay, let's look at this one. So again, if there are no exponents, part of that invisible math is slap an exponent on it, like this guy right here. So what I would do is combine everything upstairs, combine everything downstairs, and then we'll flip things around. So upstairs we have x negative 10 and 4. That's going to be x negative 6 because we add those together. Y5, y1, that's y6, and then y negative 3, so that's y to the positive 3 power. Over x negative 3, x2, that's going to be x negative 1, and then y negative 6, y 10 is going to be y to the 4th power. Now, you can do subtraction. You can say negative 6 minus negative 1, but I tell you, a lot of kids mess this up because you get double negatives and you forget. So I just say fix your negative exponents. So we're going to rewrite this. This negative 6 is going to go downstairs. This negative 1 is going to go upstairs. So x to the 1 power, y to the 3, over x to the 6th, y to the 4. So you see I just flipped just the negative ones. I kept those y's where they were. Now, in this case, what we can do is say, get rid of this 1x, and that leaves us with 5x's here. Get rid of all 3 of those, and that leaves us with 1y here. So upstairs, I've gotten rid of everything. That means that I have a 1 left, not a 0. So 1. And then x to the 5th, y to the 1. X to the 5th, y to the 1. All right, let's try this guy. So remember, if an exponent's not shown, slap a 1 on it. We're going to do that right here. Now we got to do some distribution. Oh, and right here. Yeah, there we go. Okay, so now we got to do some distribution here. We have x to the 1, x to the negative 6, y, and then this negative 3 goes to the 1 and to the negative 2. So x, so that's going to be y to the 1. Probably should have put a little 1 there. So that's x negative 3, y to the 6th, positive 6, because negative 2 times negative 3, over y6, y negative 3, x6. All right, so that's all messy. Let's clean that up. Upstairs, we have our x's. 1, so we have negative 6, negative 3, that's negative 9, plus 1 is negative 8. So x negative 8. And then we have y1, y6, that's y7. All right, downstairs we have x6, and then we have y6, y negative 3, so that's going to be y3. Okay, so we can take those 8, that negative 8, and we're going to move that downstairs. Like I said, we're going to fix all of our negative exponents. So we're going to say, okay, x, so the y7 stays there, and downstairs we now have x6, x positive 8, and y3. So we can get rid of all 3 of those y's, which leaves us with just 4 y's upstairs. At the same time, we can add these guys together. So that's going to give us y to the 4th over x 14. I had to think about that for a second. Okay, so let's take a minute and we're going to do the practice problem. So hold on. Okay, so as I mentioned, we'll go over circles in another video. We're going to do the practice problems here. Pause the video, do these practice problems, come on back, and we will talk about them. Okay, so for this guy, we've got a negative 2 there, so we're going to say 1 over negative 4 to the 2 power. Now, there's no parentheses involved, so it's 1 over negative 16. We do 4 squared, and then we slap that negative on it. So 1 over negative 16. Now, over here, what we're going to say is 1 over negative 4 to the positive 2, because I now moved it downstairs. So I've changed that attitude. Same with A. I moved it downstairs. So quantity negative 4 squared is 16, but we have to slap that negative on the outside. So we get 1 over negative 16, because all this stuff in the parentheses here would be positive 16. So it ends up as negative 1 over 16. Again, you can leave it on the bottom, top, or in the middle. Okay, for this guy. Now, this one I like because anything to the 0 power is 1, so we're just going to get rid of that. Because if we distribute it out, it's just going to be 2 times 0, 0, right? So just get rid of it. Now let's do some distribution upstairs. We get x to the 6th, y to the negative 2, over, and downstairs let's do some combining. We've got x7 and y to the negative 6. Okay, so that's x6, and now I'm going to swap my negatives, right? So I've got now y6 over x7, y2. Okay, so let's get rid of all 6 x's there, which leaves us with just 1 x here. Get rid of all 2 y's here, which leaves us with just 4 here. So we have y to the 4th over x to the 1, or just x, right? Hopefully this makes sense, and if you have any questions, leave them down below. Otherwise, great work, and we'll see you next time.